Hi guys, welcome to another episode of Rock Bottom Airsoft. It's good to see you again. If it's your first time here, then it is good to see you, and I hope you'll stick around. Okay, well, we're back to our weekend studio video. Everybody who follows the channel has been watching my series of videos will know that we normally do a gameplay video midweek and then a studio video at the weekend. Unfortunately, because I'm currently injured, I've not been able to get out to my regular game, so we're doing 2 studio videos a week. So here we are. Now, the video we did midweek, just gone, if you did see that video, then that video was about internal components for your gearbox, what they do, whether it's worth upgrading them, just a general overview of some of the components you'll find inside an AEG gearbox. Now, that video ended up being quite lengthy, so I said I'd cover the electrical system components of the gearbox in a separate video, which we're going to do today. So hopefully it'll be a quick one, just covering what the electrical components are in your gearbox, what they do, whether they're worth upgrading, so on, and how much they'll cost you. If you didn't see that previous video, then I'll put a link to that video in the description, so you can link to that there. Some of the things I'm going to cover here, I'm only going to cover them briefly, because I have done in-depth videos on some of these components, and I'll also put links to those videos in the description if you haven't seen them already, okay? And as always, before we crack on, if you are enjoying my series of videos but you haven't subscribed already, then do subscribe to the channel. That way you're not going to miss any of my uploads. Keep up to date with what's going on. And if you want any more from myself, you can find Rock Bottom Airsoft on Facebook and Instagram. Okay, well with that all out of the way, let's crack on. Well, I think we'll do similar to what we did in the last video. We'll work our way through the electrical system. Now, obviously, one of the most important parts of your electrical system is the battery, which is ultimately your power supply. That's putting power into the electrical system. I've done quite a few videos on batteries. There is a lot to cover on batteries. They are a complex thing in themselves. So if you want more information about batteries in general from myself, then I'll put links in the description to videos I've already done that go in depth into different battery technologies and why you want a certain type of battery. Okay, so the first part of any electrical system, if we start from the supply, which is your power supply, is your battery. So on any AEG, you're going to need some sort of battery to run it. Prices of batteries vary wildly depending on what type of battery you're going to be running on. So for more information on those, as I say, I'll put a link in the description to my videos on batteries. Okay, so after your battery, let's have a look. You've got your wiring loom is the most common way of looking at it. Now, this particular wiring loom is one that I removed out of one of my AEGs. I removed it because I upgraded the wiring to a thicker gauge. And what do we mean by that? Well, the gauge of wiring is, in a nutshell, is how thick the inner cores of the wire are. Now, a lot of people get confused because they think it's physically how thick the wire is. It isn't how thick the wire is, because obviously you have an outer layer of insulation and then you have your inner conductors, as we call them. The conductors, or the core, however you want to call it, but officially you've got your insulation and then you've got your conductors. Most wiring that you'll come across in AEGs, in our replicas, is stranded wiring. And what that means is you've got lots of little individual strands of usually copper conductor, and that's what carries the electrical current through your system. Now, if you have a look at this wiring, you can see that, ignoring the insulation tape on there, you can see that physically this wiring is much thicker than this wiring. But that isn't just due to the insulation. Don't judge it by how thick it physically looks. Go off the American wire gauge, which is what most of the wiring in our AEGs works on, and that will tell you how thick the conductor inside the wiring is. And that's what you're worried about. This little bit here, I don't know if you can make it out on camera, but the shiny bit inside, that is your conductors. And then you have your insulation on the outside. Insulation we'll get onto in just a second, but in order to pick a wire in, this thicker wire here is what we call 16 AWG. Now, as a general, simple way of looking at wiring, if you're going to intend to replace any wiring, the lower the number, the thicker the core or the conductor. And generally, the thicker the conductor, the more current it can handle, and the less resistance it will offer up to your electrical circuit. Now, without going fully into electrical principles here, generally thicker wire will conduct better than thinner wire, and it won't heat up as easily. A thin wire, if it's offering a lot of resistance, will create heat, and in extreme circumstances your wire will melt down. Now, that is to say, whether I think it's worth upgrading your wiring, dependent on your build. If you're going to remain relatively stock, if you're not going for an extreme high current draw build, then the vast majority of the time you have to be drawing serious current to melt down wires like these. The standard wiring in your AEG will not be offering up massive amounts of resistance when you read it compared to the task we're asking it to perform. But there is certainly going to be an electrical improvement if you use thicker wiring. But what you need to remember is if you upgrade to the thicker wiring is you have got the physical constraints of it being thicker. You need to be able to feed it through the gearbox, wire it in, without it getting chewed up by your motor pinion or without it catching or fouling on anything. You don't want pinched wires, you don't want cut insulation, and because that can cause short circuits in the system, which will be potentially damaging, can potentially cause fires if you're running LiPo batteries or any battery and it gets shorted out. Either way, it's not a good thing to pinch wires and damage wires. So you get different types of aftermarket wiring. Your first thing to look at is how big a gauge you want on your wiring, how thick you want your wiring. 16 AWG seems to be the one that a lot of people will go for with upgrades. The standard wiring is fine. You get different types of insulation. Excuse me. You can get full solid conductors where it's just one solid conductor. Now that will be very bendy. It'll hold its position. It won't be flexible like this. This is noodle. It's got silicone insulation, so it's very flexible, very wobbly, like flex. This is a hard plastic insulation, so it doesn't flex quite as much. It holds its shape, as you can see. Really, it's a judgment call on what you prefer to work with when you're buying any aftermarket wiring. Wiring can be dirt cheap, can be expensive. All I would recommend to do is if you're going to rewire your AEG, then there is a bit more to it than just buying the wire. You need solder, you need connectors, all that kind of thing. Is it worth doing? In my experience, I've found it not to be worth it unless you have specific requirements. Unless you're going for a very extreme build, then the wiring that comes as standard in your replica should be more than capable of handling upgraded motors, bigger batteries, that type of thing. You should not have a problem. You'll know if you're having a problem with high resistance in your wiring because the wires will get hot. Other parts of your replica will get warm wherever there is resistance present, such as in the motor, so through the pistol grip, that type of thing. But generally, the wiring that's in your replica should be more than capable of handling the currents that you're drawing. But as I say, if you are building something extreme, then yeah, you could look at rewiring. And wiring's very cheap. You usually pay for it by the meter. You're looking at maybe a couple of British pounds per meter. So that's part of the loom. We've got the wiring. You can see the wiring. Now your standard loom is going to have motor connectors on them. As you can see, this loom's got a bit chewed up when I was pulling it out. These are your motor connectors. They're a standard connector. They're just a tab connector. You don't need to upgrade those. The only realistic upgrade you could do on tab connectors is to solder the wires directly to the motor tabs. That's going to give you a much better electrical contact. You're not going to have any risk of arcing if these get loose, and these can work loose, and that is a common fault. If you get a fault with a new replica, very often one of these has fallen off or it's only just touching and you're not getting a good electrical contact. So that's the next part of your loom, is going to be that. And that is your motor contacts. Well, not motor contacts, but that's your connectors to your motor. They're just a push-on spade connector. Nothing special, not worth upgrading, but obviously if you're rewiring your AEG, then you're going to need your wire, and you're going to need some spade connectors, and you're going to need some heat shrink. All things worth remembering if you're rewiring, but as I say, Me personally, normally, I mean obviously I did it with this one, but you know, I don't think it's really worth it. I don't think you notice a massive performance improvement with the currents and voltages that we're dealing with. But, you know, other people have found different. Now then, the next part of the wiring loom is obviously your connector. In this case, it's got Dean's, a Dean's connector. I like Dean's connectors. You can also get a mini Tamiya connector like this, which you'll probably be much more familiar with. Most replicas will come with a mini Tamiya connector as standard. I don't like mini Tamiya connectors. I do prefer Dean's connectors. I did a video on how to solder to Dean's. I'll put a link in the description to that video if you haven't seen that one already, or if you need to know how to solder to Dean's. But that is a well worth upgrade. That I can certainly recommend on your wiring system, is definitely upgrade your connections to Dean's. The Dean's connector is far better. It gives more reliable contact. It's less resistance in the system, but again, negligible when we're talking resistance. And it's more compact, and it's a tighter fitting connection. It's just overall a better connector. It's well worth going for. So for, I don't know, maybe £3 or £4 British pounds, you get a few pairs of Dean's connectors, male and female. You want the male end on your replica. As I say, I go into detail about that in the other video I'll put a link to. But yeah, Dean's connector, that's the next part is your connector. Definitely worth upgrading in your electrical system. Well worth doing on any replica, even if the rest of it's standard. Okay, so moving down, on a lot of replicas, what you'll have next is a fuse. Now, there are arguments where people say one modification they do is to remove the fuse. I don't recommend that. For the amount of resistance that your fuse causes is negligible. And if you don't have a fuse and your replica develops a fault, then that fuse is there to protect the rest of the electrical system, and the fuse will blow instead of you blowing out motors, melting wires, or even damaging your battery. So the fuse, you want to keep your fuse. Don't get rid of your fuse unless you upgrade to a Mosfet, which we'll get on in a moment, that has a self-resetting fuse. Normally they will tell you, if they have a fuse built in, you can delete the fuse that came with your replica and solder straight to the Mosfet, and that'll prevent you needing another fuse. Some Mosfets will say they want a fuse prior to the Mosfet to prevent you burning out the Mosfet. Now this particular replica came with a Mosfet. That is a Mosfet. You know, everybody thinks of these big fancy things that replace your trigger unit. The Mosfet is just a switch. Now I did a very in-depth video into Mosfets, what they are and what they do. I'll put a link to that in the description as well. But the upshot is a Mosfet is just a switch that replaces all of the current being transferred through your trigger contacts. It sends all of that current directly to the motor, and it works off a small signal voltage, which is what these thinner wires are here. They're just for a very small signal voltage to this Mosfet attached to the trigger contacts, tells the Mosfet to close, or inducts the Mosfet to close, which then sends energy all the way through the circuit to your motor. So if you're rewiring a replica that has a Mosfet already installed, you'll probably already have these signal wires in, and you'll have the wires to your motor. But on a standard replica, these wires will run to your trigger contacts and then to your motor. But obviously I'm not going to get into completely how to rewire it. I'm just saying that this is a component of your electrical system in your AEG, and that is your wiring loom. Your connector, Mosfet, wiring loom, motor connectors, which are spade connectors, and your trigger contacts. Is it worth upgrading the wiring? No. Is it worth upgrading the battery connector? Yes, absolutely. Get Dean's. Let's have a look at the Mosfet a little bit more. You can get an aftermarket Mosfet such as this. This is a Gate Pico, very small. Basic Mosfet, just does Mosfet duties. Is it worth getting a Mosfet? Yes, it's worth getting a Mosfet. Mosfets can vary wildly in price, and there's a huge amount of different ones you can get. So I'll put a link to my other video, like I say, where I spend quite a lot of time talking about Mosfets. There's a lot you can cover on Mosfets. Price-wise, you can go from a few British pounds all the way up to 200 British pounds if you're going for something like a Gate Titan. But remember, with a Titan, you're not just paying for the Mosfet. It replaces your trigger unit, becomes an optical sensor instead of a trigger trolley. There's loads to it, loads of programming options. If you don't need that, if you're just after a Mosfet, then MOSFETs are fairly affordable. They're not very expensive, and if you want to solder a MOSFET in using the existing wiring that's there, you can do that. You don't have to completely rewire your replica just to run a MOSFET. That's not necessary. Unless you go in extreme, in which case if you're doing that you might as well replace it all anyway. But for me, I've only ever replaced wiring in one replica, never found it to be an issue. So MOSFET, that's this bit. That's a basic MOSFET that came with a replica, so that literally is just a switching system. That's a little bit more advanced, but again, you can go more and more advanced to have programmable features and all sorts, but MOSFET is definitely part of your electrical system. If you haven't got a MOSFET at all, there's a lot of people will say you have to have one because your trigger contacts are going to burn out. Now, I've worked on rental guns from my home site at Airsoft. Some of those rental guns have been running for 6-7 years. They only run on NIMH batteries, but when I've taken them apart, the trigger contacts are absolutely fine. There's been no damage to them whatsoever. There is evidence of arcing, but they're still low resistance and they still work fine. So there's a lot to be said that yes, you can burn out a trigger contact, but it's not as bad as you maybe read on the communities. But it's still worth having a MOSFET. It's a good upgrade, relatively affordable if you're willing to do your work yourself. Very cheap, very effective, and it's worth having. So that's MOSFET. So we've covered your MOSFET. So what activates the MOSFET? Let's get this out of here. This is a trigger trolley I tried modifying, but it'll do for our example here. Okay, so you've got your MOSFET, you've got your wiring loom, you've got your battery connector, you've got your spade connectors for your motor, you've got the potential for upgrading wiring, and all of this is actuated by trigger contacts. This is a set of trigger contacts that sit in your replica. If I can get them to sit upright and you can see them. So there you go, that's a set of trigger contacts. That is the shuttle. Let me put them on here for you so you can see them. If you can see that on camera, we'll try and zoom on that, but you've got a shuttle and you've got your contacts. Basically all that's happening is when you pull the trigger, these contacts are making and breaking inside the gun. As you can see, that'll sit in there, and when you pull the trigger, that will push forward in there, and you can see that will make contact with those. And that's the trigger contacts that everybody will tell you will burn out. They're quite heavy contacts normally. If they're good quality contacts, they should be fine, but when it pushes in, that makes contact. The basics of how it works, there is a cutoff lever. If you're on full auto, obviously when you pull the trigger and hold the trigger, that's just going to hold that trolley in, so you've got a permanent contact, so it keeps the motor running and that keeps your replica firing. When you're on semi-auto, there is a lever that will cause this trolley to go in and then it lifts up and lifts out and back. So every time you pull it, it goes in once and then flops out and comes back, and that's how semi-auto works. But they're still working off these contacts, and every time they make, you can get a little bit of arcing, and that's what people refer to as causing burnt out trigger contacts. What the MOSFET does with these two signal wires, the MOSFET basically replaces the high current going through those contacts, and it's just a signal voltage that's going through those contacts. Very low current, and all the power's directed to your motor. So the trigger trolley, is that worth upgrading? To me, no. Unless, of course, you have specific requirements. You can replace these with micro switches. A lot of replicas will come with micro switches as standard, such as the ETU, electronic trigger unit that you will find in a lot of G&G replicas. They come with a MOSFET and they come with micro switches instead of one of these trigger trolleys. Micro switches are fine. They can wear out a little bit quicker than a trigger trolley. With a MOSFET they should be alright, but they can wear out. I would not normally recommend to upgrade to micro switches. If you've got a standard trigger trolley in your replica, then the trigger trolley is fine. If you want to upgrade your trigger contacts, then you can replace them all together with something we mentioned earlier on, and that is an optical MOSFET. It's a printed circuit board with MOSFET functionality in it, primarily though, such as a Titan. A Titan replaces that trigger trolley and trigger unit altogether and works from optical sensors. So you no longer have an electrical contact causing the motor to spin, causing the MOSFET to close. It's basically working off light. There's a lot of people who will swear by Titans and the optical sensors. I've not got a lot of experience with them myself. From the reading I've done on them, it's not an avenue I've particularly chosen to go down. They're very expensive. I believe they can be quite temperamental to set up from experiences some of my friends have had. And some reading that I've done, but I believe you can get amazing functionality out of them. So I'll reserve judgment, but it's not something I'll use, so I won't comment too much. But that is the only reason I would upgrade your trigger contacts. If you're looking at wanting to go with an optical MOSFET, then upgrade. But otherwise, whatever's in there as standard will do you fine, even if you're upgrading other parts of the replica. So that's your trigger, that's how that works. Then, another part of the electrical system, if you want to class it as part of the electrical system, is this. And this is your selector plate, which has a small copper contact on the back, which makes a contact on the reverse here of your trigger. And that's to do with safety and semi. We don't need to go into that in too much details. You don't need to upgrade that. Unless you've got a very brittle clear plastic one, same as what we mentioned with the tappet plate in the previous video. These SHS ones are fine, the polymer ones are a little bit stronger, but on the whole, well, as you can tell, they're still in the packets in my case. I've never had to upgrade one of these selector plates. The only time it's worth having one really, I have them as spares just in case it breaks when you're removing the gearbox from an AEG. I haven't had one break on me yet. These tappet plates are specific to your particular gearbox. This one's a version 2, so make sure you get the correct selector plate for your particular gearbox. These are about £4 or £5 British pounds, maybe less depending on where you get them from. But again, not really worth replacing unless it's broke. If the one that you've got isn't broke, then it's not really an upgrade replacing that. It's not really an upgrade replacing the trigger contacts, unless of course you have a specific requirement like an optical trigger or something like that and you're going for real hair trigger setups. And then last, but by no means least in your electrical system, is your motor. I've done lots of videos that cover motors. Look through some of my previous motors, I've said that it's a well worth upgrade. This is another thing that is worth upgrading on the majority of affordable replicas. The motors tend to be slow and underpowered on a lot of replicas, not all, but if you want to increase your rate of fire or indeed trigger response, then one of the easiest ways of doing that is by putting a high torque motor into your replica. I exclusively use high torque motors. I don't tend to use speed motors. The difference being is high torque, generally, to put it very simply, high torque doesn't spin as fast, but it can pull a heavier spring back, whereas a speed motor spins a lot faster, but it can't pull as much torque back, if you like. It hasn't got as much torque, so it can't pull as heavy a spring or system. So what that means to us is that a high torque motor will give you really good trigger response, even on a light spring, but when you've got the trigger depressed and it's up to speed, it won't run as fast as a high speed would. But a high speed takes a while to speed up to its maximum RPM, and if you've got a heavy spring in there, it's going to struggle. So basically, a high torque is what I tend to go with, or balanced. You can get balanced motors as well, but high torque is what I tend to use in all of my upgraded replicas. There is one exception. You may have seen a lot in the social media about Warhead Industries induction motors or brushless motors. Brushless motors give you the best of both worlds. They give you high speed and high torque. They're just a much better technology than brushed motors. They're much more expensive than an upgraded high torque motor, but they do give unbelievable results. Sometimes a little bit too fast if you haven't prepared your gearbox with the mechanical aspects to withstand the speed at which it'll run it. If you're wanting to get an affordable upgrade though, for around about £30 British, you should be able to get an SHS or Rocket high torque motor. If you wanted to go extreme, one of the Warhead motors are over £100 British, so they do get quite pricey. But like I say, a £30 high torque motor will serve you absolutely fine, and you will notice a significant improvement. It's definitely, you can tell that it's made an improvement. So to recap on the electrical system, you start with your wiring. You got your wiring, your battery connector, definitely worth upgrading to Deans if you haven't got Deans already. You then have a fuse and a MOSFET. Do not delete your fuse unless, of course, you have a MOSFET that's got an inbuilt fuse, and then you can delete it. Different gauges of wiring. The lower the AWG number, the thicker the gauge of the wiring. Then you've got your motor connectors, which are just spade connectors, nothing to upgrade on them. I don't recommend upgrading your wiring unless you've got a specific requirement. If you've already got a MOSFET, I don't recommend upgrading it until it breaks, again, unless you have a specific requirement. Trigger, you've got a trolley. I wouldn't recommend upgrading one of those unless yours is damaged, then you might need to replace it, or unless you want an optical trigger or something along those lines. Your selector plate, definitely not worth upgrading unless yours is broke. And then your motor, that's a well worth upgrade as well. So the main things I think we've covered there, the upgrades to your electrical system that you'll have noticeable improvements and worth doing, is motor, that's a definite. Deans connectors, just for convenience more than anything else, well worth doing. If you haven't got a MOSFET, well worth installing a MOSFET. So that's it. Connectors, MOSFET, motor. That's what I'd recommend. And as I mentioned in videos I'll link, your battery can have a big effect as well. Okay, well, I hope you found that video useful. I hope it's given you a bit more insight into some of the components that you'll find in the electrical system of the gearbox when you're opening one up. If you did enjoy the video, then please do drop a like on it. If you have any questions for myself about the electrical system in your AEG, or indeed about Airsoft, or any questions in general, then do drop me a comment below. I'll always respond to comments. Might not get back to you straight away, but I will respond. And apart from that, I'll look forward to speaking to you again in the next one. Thanks very much for watching.